Let's take a look at example 3 from section 8.1. We're asked to solve for triangle ABC if angle A is 43 degrees, A is equal to 81, and B is equal to 62. Round the lengths of the sides to the nearest tenth and angle measurements to the nearest degree. For this question, if we take a look at the starting information, we have a case where we have side A, side B, and then angle A. So this would be specifically that SSA case, where we have two sides and the non-included angle. And this puts us kind of in the ambiguous case for the law of sines. To start the problem, what we should do is calculate that value of h to see how A compares to h. H is equal to B times the sine of angle A, which is 62 times the sine of 43 degrees, which is equal to 42.2. If we compare, we see that A, which has a length of 81, so A is bigger than H, and A, which is 81, also happens to be greater than B. So this is the case where we will get one triangle. So this particular problem does have a solution. There's going to be one triangle, and that one triangle is going to be unique. Now that we know that, we can kind of proceed to solve for that triangle. So our goal, as always, is we want to know the lengths of all of the sides. So we want to know side A, side B, side C, as well as angle A, angle B, and angle C. Let's write down the ones that we know first. We know side A is 81. We know side B is 62. And we also know that angle A is 43 degrees. The next thing we can solve for, we know a pair of sides. It's going to be a side and its angle pairing. That's A with angle A. So we should be able to use that information to solve for angle B. Let's go ahead and do that. If I set up this law of sines problem, it would say the following. A over the sine of A would be equal to side B divided by the sine of angle B. So we want to use this now to solve for an angle using the law of sines. This is something we haven't quite done yet up to this point. In order to solve for angle B, I first need to get B out of that fraction. So we can begin by multiplying both sides by sine B. If we do that, this is going to give us sine B times 81 over the sine of 43 degrees would be equal to 62. And then to get the sine of B by itself, I want to remove or get rid of that multiplication by 81 over sine of 43. You can either divide by it, or it's just equivalent to multiply both sides by the reciprocal. So we would get the sine of 43 degrees over 81, multiplying to both sides. These cancel out, and we see that the sine of B is equal to 62 sine of 43 degrees over 81. At this stage, we can plug this right-hand side into the calculator to find that the sine of B is going to be approximately I'm not done yet, so I'm not going to round this too much. I'm going to carry out a few digits here, but it's going to be 0.5220, I'll go one more, 3. So that's what the sine of B is equal to. I can solve for b by applying the sine inverse to both sides. So b is going to be equal to the sine inverse of that 522023 number. And we were asked to round our angles to the nearest whole digit. So if I do sine inverse of 0.522023, we would get 31.46, which is going to round down to 31 degrees. So we know b is going to be 31 degrees. Now that we know the measurement of angle B, we can add those two together and subtract them from 180 to find C. Angle C is going to be 180 minus the sum of 43 and 31, which would be 106 degrees. So that gives us the measurement of angle C. And now that we know angle C, we have side A and its angle pairing. We can set up a law of sines to solve for side C. To solve for C, we have that the ratio of side A divided by the sine of A would be equal to side C divided by sine C, which is 106 degrees. To get C by itself, multiply both sides by the sine of 106. And this will tell us that C is equal to 81 times sine of 106 degrees divided by the sine of 43 degrees. If we plug that into our calculator, that will produce a side of C, which is about 114 point, to the nearest tenth, it would be 0.2. So the length of side C is 114.2. And that's it. We've now solved for the length of every side and the measure of every angle. And as we said, for this particular problem, we got just one unique solution, just one triangle that could be formed with the starting information. Let's take a look at the next one. In example 4, they say solve triangle ABC if the measure of A is 75 degrees, A is 51, and B is 71. We were asked to round lengths to the nearest tenth, and again, angles to the nearest degree. If I look at the starting information, I have side A, side B, and angle A. That's two sides and the non-included angle. So that's the SSA case. So this is the ambiguous case. We should begin by calculating the value for H first. H is equal to B times the sine of angle A. H is equal to 71 times the sine of 75 degrees, which gives us a value of H that's going to be equal to 68.6. If we compare H to side A, one of the things that we see is that H is bigger than A. And what that means is it's going to be impossible to form a triangle with the given information. Side A would not be long enough in order to connect to another side to make a proper triangle. So there's going to be no triangle for this one with the given information. Or if you want to, you can put good old school no solution.